let's get into a little bit of derivative practice. So here we have 10 derivatives to take, and the goal before taking calculus is not to know every single derivative rule. There are tons of derivative rules, but it is to have some sort of foundation. Maybe know like 3 or 4 rules and have like 2 mastered. That would be amazing. So the hardest part about taking derivatives typically to start is that maybe you know the rule, but you don't know when to use it. So you're gonna get to that point where you're like, I know the derivative of e to the x, e to the x, but I don't know when to use that always. So we're just gonna walk through these problems and we're gonna figure out how we know which rule to use and then go ahead and use it. So looking at this first example, we have for letter A, y equals x to the 7th. Okay, first piece, base is x and the power is a number. So I'm going to bring down that power, subtract 1 for the new power. So derivative of y is y prime. I'm going to bring down that 7 and raise x to the 7 minus 1 is 6. All right, done with the first part. Now I have x to the 3rd. So I'm minusing x to the 3rd. So I'm going to minus here as well. And again, x is the base. The number is a power. So if we have a power that's a number, we're just going to bring that down and subtract 1 from the new power. So 3x to the 3 minus 1 is 2. Now we have just a number next to x, and that's our mini rule. The derivative of negative 8x is negative 8. If it was the derivative of 15x, that would be 15. Derivative of 24x is 24. Derivative of 6x is 6. So derivative of negative 8x is negative 8. Lastly, we have a constant. We just have a regular 4 at the end. It doesn't have an x on it at all, so its derivative is just 0. We could write minus 0 at the end, or we don't usually write anything. So our derivative is y prime equals 7x to the 6 minus 3x squared minus 8. Now if we move over to letter F and just kind of talk through what to do, the first thing we have is the natural log of x. So there are a couple options here. When we're finding f prime of x, we could just have it memorized. What is the derivative of the natural log of x? You might not know it now, but eventually you'll just remember it's 1 over x. Always for the natural log of x, the derivative was 1 over x. The method to that, another way to think about it, is when you have an ln, you get to just cover it up and think about what's the derivative of the inside piece over the original inside piece. So the derivative of the inside piece, derivative of 1x is 1, that's our mini rule, over the original inside is x. So either you might have it memorized, it's always 1 over x, or cover up the ln with your finger, and derivative of the inside is 1 over the original inside is x. Next piece, we have x to the 10th. X to a number, I'm going to bring down that number and subtract 1 from my new power. Bring down the 10, 10 minus 1 is 9. Then I have minus, the derivative of e to the x is always e to the x. So if you have just e to a regular x, its derivative is the same as the original function. Okay. Moving down to letter B here, we have g of x. So the derivative is going to be labeled g prime of x, so getting used to putting labels on things. I have e to the x plus 7 to the x. So first of all, e to the x, sigh of relief. The derivative of e to the x is just e to the x. The question and the answer are the same exact thing. Just get to copy it down. 7 to the x is very similar. The answer isn't just 7 to the x, though, because I have a number besides e raised to the x power. So when x is the power, we don't bring it down and subtract 1 or anything like that. Derivative of e to the x is e to the x. Derivative of 7 to the x is ln of 7 times 7 to the x. Ln of your base times your base to the original power. So we've had 3 different rules outside of x to a power type thing. Let's practice those with letter G here. The derivative of y would be labeled y prime. If you have a number to x, number raised to the power of x, that's when your derivative is going to be ln of your base, base to the original power. Ln of 3 times 3 to the x. E to the x, I could do ln of e times e to the x. That wouldn't be wrong, but ln of e is just 1, so normally we wouldn't write a 1 out front. So I'm just going to remember e to the x. Sigh of relief, the derivative of e to the x is just e to the x. The derivative of 3 to the x was almost just 3 to the x, but it had an ln of 3 out front. Ln of 3 times 3 to the x. Derivative of e to the x is just e to the x, minus the derivative of the natural log of x is always you can cover up the ln, derivative of the inside, derivative of 1x is 1 over the original inside is x, or you might have it memorized, the derivative of the natural log of x is just 1 over x. Either way, that's our rule 9. Okay, looking at the next two, they look very similar. They both have base e, and they aren't just e to the x. They're e to something that's more than just x. So these are going to be the same exact derivative rule. If you have e to a power that is more than just x, first take the derivative of the power, and then you get to copy down e to the original power. The answer for all of the e problems has the problem in it. So the answer has the question in it. Let's look at this h of x. The derivative would be h prime of x. It's our rule 6. We're going to take the derivative of this power. We didn't do it up here because the derivative of the power derivative of 1x would just be a 1 out front, so we didn't have to. But now that our power is more than just x, we're going to take the derivative of it. And so we have x to a number. We'll bring down that power, subtract 1 for the new power. X to the 3 is going to be 3x squared. We're going to do minus, and we're going to bring down that power 2 and raise x to the first, so minus 2x. And then we just have a constant at the end, so the derivative of that is 0. So we take the whole derivative of the power, and the question is in the answer. So we're going to raise e to the original power. Derivative of the power times e to the original power. One of the harder rules so far, that rule 6. Let's do that same exact thing again though. We notice we have e, and it's not just e to the x, it's more than just an x. So when we take g prime of x, our derivative, we're going to take the derivative of the power first times e to the original power. So derivative of x squared is 2x. Derivative of negative 5x is negative 5. So we brought down the power, subtracted 1 for the new power for that x squared. And then our mini rule, derivative of negative 5x is negative 5. There's the whole derivative of our power. It needs parentheses around it, times e to the original power. All of these exponentials have the question in the answer. Derivative of the power times e to the original power. Okay, it's progressively getting harder here. We have letter D. It kind of looks like the one above, where you have x up in the exponent instead of the base. It's not x to the 5th, it's x is way up there. So we have 3 raised to the x to the 6 plus 11. So it's very similar to the one that we had before, but instead of base e, we have base 3. So we're going to use our rule 8 and just work through it. First of all, with any exponential, if the power is more than just x, we're going to take the derivative of that power. So when we take the derivative of x to the 6, we get 6. X to the 6 minus 1 is 5. Plus 11, I'm not ignoring that 11, but it is a constant, so it has a derivative of 0. So there's the derivative of the power. And since our base is not e, we need to follow our pattern. So here the base wasn't e, so we had an ln of 7 in there. Here the base was 3, so we had an ln of 3 in there. So we're going to follow that same pattern with this one. The base is 3, so we need ln of our base, and then all of these exponentials end with that answer there. So we have derivative of the power. That's where 6x to the 5th came from. Ln of your base, when your base is not e, you need to have ln of that number, that is your base. And then your base to the original power. You get credit just for copying down the original question as part of your answer. Let's do that again. We have 2 pieces in the next one. So h of x, its derivative is going to be h prime of x. The derivative of 4 to the x follows our pattern from above. So we've done a couple of these. Let's look back. 4 to the x looks similar to 7 to the x. Derivative of 7 to the x was ln of 7 times 7 to the x. Derivative of 3 to the x was ln of 3 times 3 to the x. So we just have a number to a power that's a regular x. So we're going to go ahead and say derivative of 4 to the x is ln of 4 times 4 to the x. Now this next piece looks just like the problem before. So what did we do when we had 3 to a power that wasn't just x? First, we took the derivative of the power. Then we said ln of our base to the original power. Let's do that here. So we have plus derivative of our power. Derivative of x to the 9th is 9x to the 8. Derivative of negative 10x is negative 10. Derivative of the power, ln of the base is 8. And then all of these exponentials end with the original problem. X to the 9th minus 10x. Derivative of the power, ln of your base to the original power. Our longest rule so far is that rule there. When you have a number to a power that's more than just an x. Derivative of the power, ln of your base to the original power. One last rule to review, and I would do this same sheet over and over with and without the video as much as you can. It's just like other classes. You know, if it was biology, you would make note cards to remember a bunch of different things. And you wouldn't say, well, I'm not going to flip through the note cards because I wrote them down. No, you would write them down just to do repetitive studying over and over again, flip through them as many times as you can before you test it on them. So with math, we don't usually do note cards, but I would suggest just doing the same problems over and over again. You will learn the pattern. So one last rule, and then we will just practice over and over. So we have ln of something. For any ln, I usually just put my finger right on the ln and do the derivative of the inside over the original inside. So I'm going to get points just for knowing the original inside. So derivative of the inside, we have x to the 20. So our power is in numbers. So we're going to bring down the 20 and raise x to the 20 minus 1 is 19. Bring down the power, subtract from the new power. Our mini rule here, derivative of 5x is 5. And then we have a constant. So its derivative is 0. You don't have to label it. I'm just showing you. I'm not ignoring it. And then I would normally uncover the ln. Any ln, derivative of the inside over the original inside. A lot shorter than some of those exponential rules. Let's do it one more time for good measure. We have ln of x to the 13th minus x plus 2. I'm going to cover up the ln and do derivative of the inside. So I'm going to bring down that 13 and raise x to the 12. Bring down the power, subtract from the new power. Derivative of negative 1x would be negative 1. Derivative of 2 would be 0 because it's a constant. Derivative of the power over, or derivative of the inside over the original inside. So we have x to the 13 minus x plus 2 goes in the bottom there. Derivative of the inside over the original inside is what we're thinking for these ln problems. Derivative over original. And there's our review of the 10 rules. Again, do this as many times as you can and you will be ready for calculus.